Anyway, let me do the intro real quick. So, if you're new to the stream, welcome. Thanks for joining. If you're seeing this for the first time, this is a stream where your host, Nico, Roan, Talron, Slim Chicken, I go by many names, but the fact is, I'm here for you, brother and sister. And, well, actually, I'm here for myself, but I wanted to share this experience for a number of reasons. So, this is the first stream of what's going to be mini streams over a long period of time, and it's going to include the current content, which is what we are on currently. Yeah, what we are on currently, which is episode 20 of learning the Swift programming language. So the book, the literature you see on your left, is the greatest, I'll say, series of programming language books out there, in my opinion, just because it's verbose in all the right ways, in the ways that many teaching books are not, which is very annoying because the whole point is to teach people how to program. But okay, so anyway, the point is we got the good one, which what it is the Big Nerd Ranch. That's the, if you're curious, I'm not affiliated in any way. I'm just a customer, a happy, satisfied customer. So if you want to find a good book, generally speaking, on programming languages or technology, I would say Big Nerd Ranch, a Google search of Big Nerd Ranch guide and then insert whatever thing you're trying to learn is a worthy search, because if you can find one, I would recommend going for it. But anyway, that's the literature we're using on this stream, right? So we're going through it. Everything is on stream. There's nothing, I'm not doing anything with this whole experience off the stream. That's kind of the point. So we're going to learn Swift, doing this deep dive. As you can see, we're on just about page 300 of an 800-page book. A lot of content to cover. After we learn Swift, or I should say after we get through the book, cover all these things in Swift, we'll do a stream where we just do basically a refresher for each chapter, and we'll attack each of these challenges that are listed in the book. And then at that point, I'm going to coagulate everything, or I should say aggregate, not coagulate, since this isn't human blood. So I'm going to aggregate all of the notes, the highlights that you see here. That's all captured in the Kindle notes or whatever. So I want to share this with everybody, just so it's going to be useful for me too, obviously, but I'm just going to put it on a public board, just an app. It'll be a link where you can go to a visual whiteboard and just see it. And that's just, I'm not going to charge for it, obviously. I'm just saying there will be a recap. That's the takeaway here. So I actually want to make this not just a learning experience at my own pace, because I know that's difficult. So I guess you could say, more or less, for the audience currently watching the stream, or anybody that watches the videos, I would say, generally speaking, and this is going to sound counterproductive, but yeah, it's going to be hard to learn Swift just watching the videos unless you're coding along. And even at that, it's going to kind of be difficult because you're having to go at my pace. When I want to stop and talk, I stop and talk. When I want to go to the bathroom, I just go to the bathroom. So there's a lot of breaks and cuts, is my point. But I do still think it's meaningful, only because I'm going to put forth effort to talk through each thing that I'm seeing. So I guess my argument in terms of the value you would get is you're still going to learn something, and eventually, or I shouldn't say eventually. The other upside is, eventually is the right word. But it had a negative connotation, but don't take it negatively. But eventually, everything's going to tie together. So we're learning Swift now, okay? After we do this, we're going to go straight into SwiftUI, which is just a framework, the modern framework, basically, for Apple, a declarative framework to write interfaces for, Mac OS, iOS, all the OS, Apple OSs, effectively, and even HTML, even for web, because I know there's some compiler work going on to compile, SwiftUI to what would effectively be your HTML and CSS. So Yeah, so it's going to be worthwhile, and I'm doing them in that order because it just makes sense to me. There's no reason to learn a framework if you don't know the underlying language, in my opinion. So Swift, SwiftUI. After we do that, and SwiftUI won't be a big nerd course, but it is going to be a structured course still. Not that you guys are going to have to pay for it. It's something I paid for that I'm also going to do, on the stream is the point. So, I am being optimistic. I'm sure it's not garbage. It had good reviews, but I'm just saying the SwiftUI component will not be a big nerd range guide. It'll be just a separate course that I found on the web and it looked good, so I picked it up. Okay, so we're going to do that. I can't imagine that's going to take more than a week. I hope not. Probably not. Then we're going to do basically just some planning. So as part of this, you'll learn I'm starting, or I shouldn't say starting, I started a company, NodTech, and I want to publish apps under that banner. I have a specific app in mind, which is the reason why I'm learning Swift. So I'm a person that knows SQL, a person that has, I guess you can say I know Golang. I don't feel like it's, like I know SQL. I don't feel like I know Go like that. You know what I mean? You can just say you know certain things. Other things you're like, yeah, I can use it. I can utilize it. But do I know it? Like, no, I don't feel like I know Go like that. Although Go is simple, so that's one of the upsides. But anyway, after 10 years in the industry, working for a service company that specialized with, we were a reseller of an ERP package, right? Accounting systems, SAP, Microsoft Dynamics, things like that. But we also had an in-house manufacturing program that was directly integrated with that ERP package. And it did a lot of interesting things. And one of the two main things that I want to key in on that I see a big opportunity for now, having split with that company after... Come in, babe. Do you need help? Huh? Do you need help? Okay, never mind. Hi, babe. She says hello, y'all. Right, babe? I said you said hello to everybody. Yeah. She's carrying like 90 pounds, which is like 500 pounds to her. Or not 90 would be crazy. 20 pounds. Anyway, what was I saying? Oh, yeah. So, FSMA. When FSMA was introduced, it introduced this requirement for food traceability for lots. So anything that has a lot number, anything food, basically. You might heard it called farm to fork, or what's the other thing they call it? I forget. We called it cradle to grave. But basically, you need to know, like if you buy, let's say you're a hot sauce maker, because we had a hot sauce customer, and you order salt and cilantro and all kinds of veggies, whatever, all that stuff goes into your sauce they make. But whenever they produce it, they're producing it at scale because their customers are other businesses, not, in customers like us buying little jars. So they make these huge kettles, a 5,000 gallon kettle full of sauce. And so everywhere that sauce ends up getting bottled and shipped to, you have to be able to track that in the event of a recall. And you only have, by law, you have 4 hours to get that information. So in the event of an audit, because they do these random audits where an auditor will come on site, go out into your inventory, grab a few, labels, barcodes. Hopefully you have barcodes, set up. Some people didn't even have that. And they say, show me your recall paperwork for these lots. And so you have to be able to track who you bought it from, how much you bought at that time, how much was on the truck when it showed up associated with that lot, how much is associated with that lot specifically. If you did an inventory adjustment in the system, you have to be able to prove that that was scrapped and not, put into a production run. And you have to be able to know all of your customers that you shipped it to and on what dates and what quantity, all that stuff. So a lot of touch points, right? So almost immediately start thinking about things like vector databases, something like that. But we didn't have that, and so there was a lot of pain points around not only the traceability aspect, but also just current inventory levels, something we refer to as MRP, Material Resource Planning. So that's basically just it's an ongoing dynamic calculation at any given time of, what are my stock levels? What's my current sales demand? What inventory do I have on the way to fulfill back orders? So, people don't have infinite space. So they have to be strategic about when and how much you buy of a certain thing, especially if it's something that, like the customers that used, who was one that we had, that you guys might have heard of, Snap Kitchen. If you ever heard that? I'm down here in Dallas. I don't know how big they ever got, but they basically made, have you ever heard of Meals on Wheels? The government program, Meals on Wheels? That's effectively, it wasn't free, but that's what they did. They made fresh meals and then would deliver them. So it wasn't frozen food. It was fresh food. And so, there's a time constraint there. So, whenever you're using organic material and you're ordering it, you can only, keep it cool, but for so long. Or it can only, not be cooled, but for so long. So there's all these considerations you have to make, all these different touch points relative to the equipment that you have on hand, the space you have on hand, the personnel, the scheduling, all that stuff. That's what MRP Panda is going to solve, but it's going to focus more on the MRP portion. And I want to use Swift for that. Not so much, it is very expressive, and we've seen some cool stuff that it can do so far, like the enums, like the case handling, like the function types, returning functions, stuff like that. That's all great, but really and mainly it's about Swift is just the best option for the hardware, and I want it to be an app, first and foremost. Because, people are out on the floor, blah, blah, blah. Anyway, so that's what we're doing. So that was a long intro, but if that strikes your fancy, then you're in the right spot. And so we're going to build it on the stream too. So there's going to be a very long-lived goal. There's no real rush. So yeah, so that's what it's going to be about. So if you dig it, stick around. If not, get the hell out. No, I'm just kidding. But really, you should probably leave. Okay, so now we pick up back where we were. And I didn't do any, I was talking all that shit yesterday. I don't know. I'm just going to live with it for now. I kind of looked into, this is the last aside, and I swear we'll get going. But, so I got you guys know what they look like. I just got an iPad Pro, and the M2 one, not the super new one. I learned my lesson buying new stuff. It's never worth it. But anyway, you can technically write apps on the iPad. You don't need a Mac. So the conventional knowledge, at least as of, I don't know, when did I start doing this? Like, let's say 4 or 5 months ago, when I'm looking into, like, how can I build iOS apps? First, I looked at, there's a really interesting implementation through OCaml, which I found interesting just because I really like the OCaml language in general. I just, like, if you're somebody that writes a lot of Excel functions, you could probably catch on to that pretty quick because it's all functions. So it's great. I don't know. Made a lot of sense, but that ecosystem kind of fell apart. So that whole idea then fell apart. And then I saw that Odin, if you guys have heard of Odin, which is more of a, it's a lower level language. It's more, I guess you could call it like a alternative to C. but it's really mature. It has apps in production. Just Google Ginger Bill Odin. Seriously, that's his name. Ginger Bill Odin. If you don't know about it and you want to learn a good, modern, mature, low-level language, Odin is awesome because it's used in-house at a company. So Ginger Bill is the author of Odin. And he works for, I can never remember, I think it's called Embergen. Yeah, Embergen. Embergen. I can just show you guys right now. Let's just give Odin a quick plug. But yeah, so look at, because this was almost an Odin stream until I realized this is a little too much programming language for me, if I was being honest with myself. Just because, like I said, it's lower level. But so this product, Odin, right? Or Embergen. What do they call it? Something liquid smoke effects, something. But basically, that's what it does. So lots of, like, undoubtedly, if you've watched like any of the Marvel movies, as a good example, any of the smoke effects were probably created, by Embergen. But so I mean, it's unique in that for the most part, you would never see a language as young as Odin already have a mature application like this that's actually being sold and used in production at this scale. So it's pretty impressive. So like this alone gets you past a lot of the humps, Although I will say that as a newbie coming into it, I think more than likely, like, you'd probably want somebody on hand that at least kind of knew C initially, because then you could really rapidly pick up the context and just kind of say, okay, that's how it works in C. This is how Odin changes that a little bit, and then it would make a lot more sense. But either way, great language, a great story that you won't really find elsewhere. And so if you're into that, I would definitely come check it out. But the language itself is it Odinlang? Yeah, odin-lang.org. It doesn't have, he has said the language is done, like it's complete. Not really planning to add a whole lot more to it. There's no official spec yet, but there is the demo. This will take you to their GitHub, and he has examples for everything that you could possibly do within the language itself. So to me, there's enough material there too to teach you adequately if you wanted to learn it. So yeah, this to me is a very safe option. Now, I brought this up because they're one of the few languages that already has full support for Metals, which is the Apple Systems API. So you could write GUIs with Odin for iOS or for Mac OS, that kind of a thing. But anyway, yeah, that's one that I looked at. V was another programming language that had that, but ultimately Swift was just a better fit because coming from SQL and Go and just like a tad bit of JavaScript whenever I needed to, this was more accommodating. Plus, they're adding a lot of, like, this year, Swift 6.0 is coming out, which is adding async, a bunch of different stuff around async, which is, it's not going to make the language perfect, but for the most part, it was one of the more larger drawbacks that people saw in terms of can Swift be adopted outside of the Apple ecosystem. Like if I just want to, like if I only have a Linux PC and I just want to write web apps, can I use Swift? And so now the answer is yes, or it's been yes for a little bit, but now with the async, you don't have to do a whole bunch of funky stuff to avoid data races. Now it's a lot more fluid. And so yeah, so it's a good time. It's a good time to pick it up. Now the thing that I was bitching about was just Mac OS in general, my general distaste for it. I even considered maybe switching this over to using VS Code instead of Xcode because it was acting funny yesterday, but I don't think, even VS Code acts kind of goofy on Mac OS. Everything's just weird on Mac OS, so we're just going to deal with it. But yeah, so that's the longest intro ever, but now we can get back to what we were doing. Did we looked at enumerations, enums. So we learned this new keyword. Here's the structure of our enum itself. Type annotation if we wanted to be specific, we don't have to be. Case left, so you just do case and then whatever your thing is. This equals is if you wanted to set an explicit raw value, but otherwise if we don't do this, so you can just do this without the equals. And so well, just imagine the 30, 40, 50 are not there. So if it was just simply case left, case right, case center, case justify, then it would assume 0 based indexing. And so raw value of case left would be 0, case right would be 1, center 2, justify 3. You see what I'm saying? So we picked up on that. That all made sense. That's pretty cool. Talk through some use cases for that. What else did we... I forget what it told us about. Oh, right, that in our case statements, if we, like here we create a mutable variable with the enum, and with one of the cases, justify. After we do that, if we call on the enum again, we don't have to say text alignment dot left, text alignment dot right. It knows what's in that enum, or what's in that variable, and so we can just call it like this. So that's what that was. And then they showed us this this chaining of the dot notation, which is cool. I like that. And then also this raw value. So that's just I guess a method you can call on any enum to get the raw value corresponding to it. So let's go ahead and command shift. Yeah, there we go. So yeah, so these raw values on the right here, 20, 30, 40, 50, it's getting that from obviously what we defined up here. And then for string, I think we I thought it said we don't even have to, maybe I just didn't delete it, but I know for strings it said if we just write the case and it's the same as the raw value. Oh, thank you, babe. If it's the same as the raw value, you don't have to write the string after the fact, so you can just do case swift. But I wonder why I didn't show. But I guess that proves it, because even though I don't have the string like all the rest here, oh no, wait, try here. My favorite language is enum.swift, which is here, and I don't have the string, so that proves it. So now you can believe me. So that's how you can do it, which is nice, because I would think for the most part my cases would line up. So it's nice to know if you can define a custom string, but otherwise don't need to. Oh, I see what they did, yeah. Now, was that... There was something around this. We did this optional binding. I think that's what they call that. The if let is the optional binding. What were they showing us? What were they showing us? Else. if let my alignment equal text alignment. Text alignment. Oh, okay, yeah. So, okay, it's saying if the raw value that I pass in here, so here's the, what is that called? Dang it. Whatever. The temporary constant. That's what I'm going to call it. Because it's an if let. So, oh, optional binding. I just said it. So yeah, my alignment, if this is equal to the enum dot, and then the argument we pass is, you know, my raw value. If it's in here, so if it's in this list, if 200 were here, then it should print the success, otherwise print the fail. And since it's 200 and 200 isn't in the list, that's why we got the fail. Okay, so I think that's about it. Okay. But did we? So you've been using int. No, we didn't get there. Start with my raw value. It just feels like a weird place that I would stop, but I don't remember. Yeah, I don't remember doing. Yeah, I guess I did. Oh, that's right. I think I just gave up because there's a lot going on. Technical difficulties yesterday. Okay, so we'll just start there. So when are raw values? Oh yeah, that's a good question. When are raw values in enumerations? When are raw values in an enumerations useful? When are raw values in enumerations useful? That sounds better. The most common reason for using raw values is to store or transmit the enum to a system that does not know about your text alignment type. Right, so you could do this to map. Like if you're passing it to some web program or an API, you could use these to pass it whatever it needs, but then you can have like an internal implementation relative to your source code. So that's pretty cool, pretty powerful. Instead of writing functions to transform a variable holding an enum, you can use raw value to convert the variable to its raw value. Instead of writing functions to transform a variable holding an enum. Yeah. Which is kind of a weird thing to say because in both cases you're using a function. That's what that is, isn't it? Inherited from raw representable. Yeah, I mean, whatever. That's splitting hairs. So this brings up another question. If you have a raw value, how do you convert it back to the enum type? Every enum type with a raw value can be created with a raw value argument, which returns an optional enum. Oh no, we did that part. That's what this was. You start with my raw value, a variable of type int. So here, 37. Then you try to convert that raw value into a text alignment case using text alignment raw value. Yeah, here. Because text alignment raw value has a return type of text alignment or optional text alignment, hence the question mark, you use optional binding to determine whether you get a text alignment value or nil back. Because text alignment raw value has a return type. Wait, so we didn't write that anywhere? This function here, text alignment. What the heck? I'll have to ask the Oracle. I just want to know why that works. Like, where's that coming from? Meaning the, like this here. Because we didn't. Yeah, we didn't do that. Brother. So let's ask. Bro, what is the deal? Oh, my little tool just isn't working. Okay. Given the below Swift code, how is text alignment raw value just a function? I'll probably have to give it the enum too, or won't know what I'm talking about. Okay, but it is built in. So if you put a raw type, then you can just call it. Okay, so it's just there. It's just a tool that Swift gives you. So that's cool. Okay, just wanted to make sure. So then, okay, so then that makes sense to me. It's an optional. You use optional binding. The raw value you used here corresponds to text alignment.left, so the conversion succeeds. Try changing the value to one that does not exist. Okay, yeah, okay, now I remember. So we did, that's when we changed it to 200. Okay, so far you've been using int as the type for your raw values. Wait, we wrote this too, so obviously we did this. So we did cover the strings. Yeah, so you only need to keep the ones that you need to customize, basically. Wait, what did it say here? Modify and program language to take out the unnecessary raw value assignments. Oh, okay, right. I'll just do it just because I'm OCD, so. Objective C. And C++. Yeah, because CPP looks stupid. Alright, so... And that's the code. We ran that. We got that. Swift. Your declaration of devotion to Swift does not change. Methods. I'm hoping I get... I would like to... What happened? What happened? Huh? Oh, I thought you hurt your foot. Where was I? Oh yeah, I hope Swift turns me into a whatever y'all call yourselves, Swifties. That's taken though. Yeah, that's taken. So you can't be a Swiftie. Swiftonian? I don't know. It's best I got. But yeah, hopefully it grows on me like that. I like it though so far. It's just like, it's a lot. It's like 4 ways to do everything. Okay, methods. Recall that a method is a function that is associated with a type. Yes, that is associated with it. I want to understand this too, so let me ask. Read a passage like the below. What does I don't like ambiguous terms. What does that mean? Associated with? Like in a module? What does that mean? Is tied or linked to a specific type. A struct. This method is tied or linked to a specific type, either a class, a struct, or an enum. This means the method operates within the context of that type, typically affecting or utilizing its properties. Man, it is. I can tell because I've been using ChatGPT for I guess right about a year now. The pro version, and yeah, I don't know. Whenever this last update rolled out, you can tell they made it way more like verbose. Like the responses are just, I mean, it's a lot. I kind of don't like it, but not enough so much that I'm gonna figure out how I can change it back. But yeah, it's a whole lot. That's not really what I wanted to know though, but what does how is how is a given method able to be scoped to a single Oh, there's access control built into Swift. Dang, that's pretty cool. Access to self inside a types method, the keyword self. That is cool. Hashtag JavaScript. Okay, well, and it's just there. I mean, it did answer the question, so that's okay. Okay, so then in some languages, methods can only be associated with classes. In some languages, methods can only be associated with classes. One more thing. I don't think Go has enums. But we're about to find out. Let's see. Swift to go. I'm blind. Where the hell is it? Oh, right at the top. Okay. Const. Yeah, but that's different because this is... That's actually assigning the value, but that's not what that's doing. So try it like this. Ah, yeah, that's what... I remember. Now. You have to do some shit like this. Yeah, that... No, that's dookie. Okay. But that's fine, though. We're not writing Go, so it doesn't matter. Okay, so... In Swift, methods can also be associated with enums. Create a new enum that represents the state of a light bulb. Okay. Enum, light bulb. Open it up. Case on, case off. Suppose you want to know the temperature of the light bulb. Add a method for computing the surface temperature. For simplicity, this method ignores a lot of physics. Okay. Func. Surface temperature. For ambient temperature. Ambient. Why do I have the hiccups? Excuse me, double. Okay, double. Return type is double. So we expect to get a double back. Switch self, open it up again. Case on return ambient plus 150. 150. Case off. Return ambient. 1, 2, 3. Wait, what? Why does that look so weird? Double, return type, double. Switch self, open it up, case on, return. Oops. That's the switch statement. What's the problem? Oh, it's all... My bad. I didn't see that it was all one. Wait, is it running or what's it doing? Maybe I never noticed. I don't know if that's just always running or what, but I guess that's that. So here you add a function inside the definition of the light bulb enumeration. So inside this enum, we write this function. Okay, switch self. If it's on, return ambient temperature plus 150, and if it's off, just return ambient. Yeah, that should work. Yeah, so then because surface temperature for ambient temperature is defined with the enum, it is now a method associated with the light bulb type. It is now a method. Oh, okay, I see. Oh, so that's how they do it. So that for raw value would also be in that enum type. So if we were to go look at the source code for enum, we'd see something similar with func raw value or whatever that implementation was. Okay. I'm gonna highlight that. That's pretty cool. Here you add a function inside the definition of light bulb enumeration because surface. Oh yeah, it's now a method associated with light bulb type. We would call it a method on light bulb. Yep. The function appears to take a single argument, ambient, but because it is a method, it also takes an implicit argument named self of type light bulb. Type light bulb. Pardon me. All Swift methods have a self argument, which is used to access the instance. Hold on one sec. Oh, was it command? Nope. Or command option space. It used to work. Anyway. I will be right back. fucking... Oh, pardon my French. I thought I changed my setting. Oh, there go the turbines. Okay. So I like this place that I'm in, but the AC sounds like a jet taking off. It just perpetually. And it runs for like 20 minutes. And it's obnoxious. But other than that, it's great. Okay, so back. Turning on the light. Create a variable. Okay, we did that. Return. Okay. This function, or the function, appears to take a single argument ambient, but because it's a method, it also takes an implicit argument named self of type lightbulb. All Swift methods have a self argument, which is used to access the instance on which the method is called, in this case, the instance of a lightbulb. Create a variable to represent a lightbulb and call your new method. Okay. Oh yeah, you can see that. Yeah, var bulb, no, light, come closer, light, bulb, at ambient temperature 77. Var bulb temperature. Wait, so var bulb, let ambient temperature, and then bulb temperature. Okay. Go bulb dot surface temperature. Oh, because bulb has the association with the enum because of the dot on. Fuck. And dot on has access. On has access to surface temp. Okay. I was wondering how that was happening. Now I lost my bulb dot. Oh yeah, there we go. For ambient temperature. Print the bulb's temperature is escape character string interpolation. Bulb temperature. What did I do wrong? I'm missing something. Var. I wonder why it's not. Bro. Light, bulb, light. Oh my gosh, dude. Stupid ass capitalization. Alright. There we go. Is 227. 150 plus 77. Appears correct. Alright. First, you create bulb, an instance of the light bulb type on 75. Oops. When you have an instance of the type, you can call methods on that instance using the syntax instance.methodName arguments. You do exactly that here when you call bulb surface temperature. You do exactly that here when you call bulb.surface temperature. Okay. You store the result of the method call, a double, which we know from here at the end of 64. You store the result of the method call, a double, in the bulb temperature variable here. Finally, you print a string with the bulb's temperature to the console. Okay. Yep. The bool type has a toggle method that flips the variable to the opposite value. Oh, cool. True to false and vice versa. It would be handy for your light bulb type to have a toggle method as well. To toggle the light bulb, you need to modify self to change it from on to off or off to on. Add a toggle method that takes no arguments and does not return anything. Right after the case off. Okay. So these things could get very large quickly. Open that bad boy up. Func toggle switch. Condition on self. Case on is self off. And case off. Oops. Case off. Self equal on. What doesn't it like? Func toggle open switch self open brackets case dot on. That's what I have. Self equal off. Case off. Self on. Switch self. Closes the function. Closes the enum. Oh, okay. You're supposed to get the error. Okay. When you enter this, you will get a compiler error that states you cannot assign to self inside a method. Inside a method. You cannot assign so. Mark method mutating. To make self mutable. What is this, Rust? What the? Okay. Alright, guess we're doing that. I don't really like that, but cannot assign. Okay. In Swift, an enumeration is a value type, and by default, methods on value types are not allowed to make changes to self. Oh, I see. Because it's a value type. I guess that makes sense, yeah. Okay. If you want to allow a method on a value type to change self, you need to mark the method as mutating, which makes the implicit self argument mutable. The implicit self argument mutable. You will learn more about value types and the mutating keyword in chapter 15. For now, add this to your code. Mutating func toggle. Okay. I guess it's not the end of the world. I wonder how common that is. Seems like that'd be a way to shave a lot of time off of things. Okay, so we add the toggle, or the mutating. Pardon me. Man, there's no sun out today. What the hell? I know I'm tired. Now you can toggle your light bulb and see what the temperature is when the bulb is off. Oh, cool. That's what I wanted to do. Okay. Bulb.toggle. And bulb. Temperature is equal to bulb. And ambient temperature. Print. Oh, wait, I did these already. Just kidding. Okay, just put that here then. There we go. Command Shift Enter. Okay. And run it again. Oh, duh. That's on, so it'll always be off. Okay, so now you can toggle the bulb and see what the temperature is when the bulb is off. 77. Cool. Okay. I like it. Turn off the light. Okay, a new thing. Associated values. Everything you have done so far with enumerations falls into the same general category of defining static cases that enumerate possible values or states. Swift also offers a much more powerful flavor of enumeration. Really? Cases with associated values. Cases with associated values. That's interesting, yeah. AKA derivatives. Associated values allow you to attach data to instances of an enumeration. And different cases can have different types of associated values. Create an enumeration to track the dimensions of a couple of basic shapes. Each kind of shape has different properties. To represent a square, you need a single value, the length of one side. To represent a rectangle, you need two values, a width and a height. Oh, I see. Okay. Oh, I see. Yeah, associated. Okay, square side, and it's a double. Not gonna write all that. Case rectangle. Type double and height type double. You define a new enumeration type, shape dimensions with two cases. The square has an associated value of type side double. The rectangle case has an associated value of type width double, height double. Both of these are named tuples. Okay. Yeah. Both of these are named tuples first seen in chapter 12. To create instances of shape dimensions, you must specify both the case and an appropriate associated value for the case. Okay. Var square shape. Hold on. Why isn't that? I wonder why it's not. Well, it's not showing my command button for some reason, but it'll show escape. It won't show shift or option. Not sure what good that does me then. Okay, so then var square shape. Shape dimensions, square side. So we pass it a value of 10 for the side. Var rectangle shape. Shape dimensions, rectangle. 5, tab over. That I like a lot, that's cool. 10, print. Squares area equal escape character string interpolation square shape area. The heck? Doesn't seem to know what area is. Oh, I missed it. How the heck did I miss that? Holy crap. Var. Switch it to unpack. Oh, I started looking down here. Jeez. Alright, here you create a square with sides 10 units long and a rectangle that is 5 units by 10 units. So that's what we did here. Okay. You can just switch statement to unpack and use an associated value. Add a method to shape dimensions that computes the area of a shape. That makes sense. That's why I didn't see it. Okay, so inside the enum, func area. It returns type double. switch self. Case let square side side side. That's what it says, side side. Return side. Oh, because we'll, okay, because we're going to pass it side. And then return side times side. Okay, and then caselet. Caselet rectangle. Width W H. And then return W times H, width times height. Okay, now it would make sense. So squares area is 100 because that's 10 times 10, and that's 55 times 10. Okay. Yeah, this I'll definitely use because you can. I mean, a few things have kind of encapsulated what the bulk of the logic that I'll need will be, but this really and truly shows it, because the fact that you can, you know, create the enum so it can be a defined listing. So if you want to give the user, the end user, say we're transforming data, or we want to let them import, you know, a certain file format. Each of these cases could be a file format, and then inside the enum, write functions that do the appropriate transformations against that standardized format. Just like, you know, just like the calculation for a area for certain shapes is standard. Other business practices could be standardized and then represented as code inside these enums, so people can, you know, transform data like they need to without it being a manual process, especially if it's become a standard, like relative to the organization, like internally. That makes a lot of sense. Because not everything's gonna have, like, globally have a strong standard, like, say, like the web standards, you know. Don't always get that luxury, but yeah, this is cool. So this, yeah, actually, let me just highlight that whole page because I want to remember those examples. And then, all right, so we printed it. Not all enum cases need to have associated values. For example, you could add a point case. Geometric points do not have any dimensions. Add a point to your enum with no associated value, and update the area method to include its area. It has no associated value. Func area, so down here. God damn, my back. I get scoliosis sitting here. Okay. Okay. Case. Where'd you put it? Under switch self. Switch self. Case. Point. 0. Okay. Now create an instance of a point and confirm that area works as expected. Wait, but enum shape point has no associated value. Oh, that was getting, yeah, okay, my bad. I was like, where's the thing? I thought that was part of the description. Okay, so it's just case point. All right. Return 0. Confirm that area works as expected. Point. Oh wait, we didn't make the, my bad. That is area. Wait, so how to far point? Okay, yeah. Point shape. Okay, so we call it enum dot point. And no parameters defined, so no arguments. Points area equals escape character, string interpolation, point shape dot area. I mean, it is 0, so 0 times 0, I believe, is 0. In this chapter, you saw how to define custom data structures to represent one of a discrete list of values. Yes. Sometimes with associated data. The Swift standard library has a wide range of types available for modeling different kinds of data. Okay. But the ability to directly model custom data using your own type is, in this way, is extremely powerful. Agreed. Yeah. So that means actually I don't know what that means, but associated values. Attach data to instances of an enumeration. Allow you to attach data. So I guess that's the attaching going on would be well, I guess it starts with how you define it, because you can set it at the case level what data would be attached, width and height. Yeah, okay. Okay, I think I know my question now. So I want to understand, because this would be defining a method against this enum. Damn it, I had it. So wait, what do I want to know? What is the relationship, I guess, between like what is what? Associated values enable you to attach custom data to the cases of an enumeration and capture relevant values at the point that you instantiate the enum. Each time you use a case, it can carry a different value. Making enums a flexible way to group related values with additional information about each case. Here's why associated values are useful. Customization, convenience, type safety. It demonstrates how okay, I mean that makes sense, but what is the are the associated where in the syntax example you shared okay, so the parameters. Okay. Yeah, okay, so we finally got there. It's referring to what we pass to it, which makes sense, but I must know. I need it said clearly and blatantly before I believe. Okay, so, alright, that makes sense then. Yeah, so that's interesting. So you really, I mean, in this one pattern right here, well, I guess if anything, this pattern right here is probably like really popular with, like if you're writing libraries or a framework, maybe not necessarily for an app developer's use, but certainly for tooling. I mean, app developers could use it too, but I'm just saying this strikes me immediately as like a really cool way to have a custom implementation of something. Custom actions against custom data types with specific method calls that you can scope to each case. Hell yeah, brother. I like that a lot. That's really cool. I don't want to forget this. So I'm going to also highlight. Because yeah, I'm going to be writing a lot of that. Man, I wonder if there's a Swift... surely there is, but... We'll look at the end of the stream. Create shape dimension must specify... Okay, where do we leave off? Because now I'm thrown off. Everything you have done. Okay, we didn't even get past this. Yeah, so everything you've done so far with enumerations falls into the same general category, defining static cases that enumerate possible values or states. Swift also offers a much more powerful flavor of enumeration, cases with associated values. Associated values allow you to attach data to instances of an enumeration, and different cases can have different types of associated values. And so we did this. You define a new enumeration type, shape dimensions. Where are you at? Shape dimensions. Oh, here. On 94, with two cases, square and rectangle. Oh wait, we're here. We're further along. Yeah, we did that. You can switch to it to unpack it in your implementation of area. Oh yeah, who am I kidding? I'm crazy. We're already here. Computing, print. Okay, we added the point. Your enum with no associated value, and update the area method to include its area. It's 0. Now create an instance and confirm that it works as expected. Then we did that. And boom, boom, boom. Yeah. Okay, so let's just, I'm curious what add parameter method to shape. I can do that one. Add another case to shape dimensions enum for a right triangle. You can ignore the orientation of the triangle. Just keep track of the lengths of its 3 sides. The orientation, you can do that too. Adding a new case will cause... Oh, so you would just need to know whatever the math is for right triangle. Implement it here. Okay. Ooh, what is that? For the more curious recursive enumerations, you now know how to attach associated values to enum cases. Yes. This brings up a curious question. Can you attach an associated value of an enum's own type to one of its cases? Can you attach an associated value of an enum's own type? Like self-referencing? Of an enum's own type to one of its cases. Perhaps this question brings up another. Why would you want to? Well, so for MRP, something like MRP, like I was saying, you would want to do that because at any given moment, when you, because there's different levels to it. There's like, on the grand scale, if you run a inventory report, just in the context of thinking about backlog, sales backlog. So you have, let's say you have like, I don't know, 10 on hand of a particular item. You have 10 sales orders, all ordering a quantity of 1. So you have 10 of those items in stock, but you also have 10 open orders to fulfill of that exact item. And so in that context, we would say you have 10 on hand, because on hand refers to just the physical presence of an item. But you have 0 available, and available is your on hand quantity minus your backlog. So 10 minus 10 would be 0. And so in that case, let's say you now receive, 5 more in there, and you get 7 more orders. This is too complicated to do verbally, honestly, but basically it's you would want it to reference itself, because every time that you have a system that tells you how many orders that you can fulfill, like we did this once, but we didn't implement that last little bit, and that's why it was causing issues. But it's hard to notice, but it's there. But effectively, we built this program where at a given moment in time, it would say, okay, print for the warehouseman out on a, if they're out there just picking items, putting them on a cart, taking them to a desk where somebody else puts them in a box, and then they ship them to you. So just think like, Amazon warehouse. Because this customer they were a distributor of tools, and they sold different packs of tooling to their customers. Well, they only wanted to print pick sheets for orders that they could completely ship. They didn't want to short ship things. They only wanted to ship out the orders where they could completely fulfill, all items. And in our calculation, we were accounting for the stock values, but what we weren't accounting for is, like, let's say we did a read on the data and said, okay, you have 10 on hand, so any sales order with less than a quantity of 10, less than or equal to, so any order with less than or equal to quantity of 10 for this item technically would be on that list. But the problem is, when you go and pick the first one, let's say you printed 5 orders that fell into that criteria. You go pick the first one, well, you just grab 10 off the shelf for that order. Even though technically all could be fulfilled by those 10, but you can only pick 1 out of the 5 orders to fulfill. You can't fulfill them all. You would need 50 in that case. You see the distinction there? So that's why it would need to be self-referencing. So if you say, okay, I'm printing these 5 orders because once you go pick the first one, even after the fact, even after you fulfill the first, you still have enough for the second, and then subsequently the third. So you would need to, like, each time that the warehouse person said, yeah, I just picked that order, now you need to reference, what do they call it? Reference recursively. in that fashion. So yeah, so that's okay, cool. So this is good. This would have a direct applicability here too. Yeah, because that program was, well, it wasn't recursive. It was using a while loop, and it was horrendously slow. But anyway, okay. So you now know how to attach associated values to enum cases. This brings up a curious question: can you attach an associated value of an enum's own type to one of its cases? A data structure that comes up frequently in computer science is a tree. Most hierarchical data can naturally be represented as a tree. Yeah, maybe that might do it. What was I gonna do? Sorry, I was reading my LinkedIn. I got another interview. I think I'll just do it and record it, make some content out of it. I mean, I'll take it seriously. I'm just saying. Already got a job. So a data structure that comes up frequently is a tree. Yeah, most hierarchical data can naturally be represented as a tree. Think of a genealogical family tree. It contains people, the nodes of the tree. Oh, real quick. I know I love tools. Let me show you guys this real quick. Because I'm showing you this because it's free, and I'm really curious what somebody with more time might be able to do with something like this, because it looks really, really cool. So here's the website, nodes.io, nodes.io. Upper right hand corner, you can just download the tool. It's an Electron app, so it'll work on anything, but it's really cool. This is it's like a visual, like if you've ever used Jupyter notebooks, just think of that, but even more freeform. So like instead of just the top down like individual cells where you write code and execute it, this is that, but also, well, you can see it. Let me just show you this picture real quick. Bro, why would I click the button and then it just keeps it the same size? It just moves it somewhere else. What sense does that make, really? Right here. So this is really neat, kind of like in Xcode where we're working now, but on the left you have these little, blocks of code. You could drill down into any of these and write little, it's JavaScript, so you have JavaScript code in here, and then you can create your relationships, and on the right hand side you get a little hot code reloading, visualize rendering of whatever it is that that you might be writing. So maybe it says nothing, but yeah, really cool for exploration, prototyping, stuff like that. I mean, look at this. Look at what, really? It's pretty incredible. And it also comes with, or not comes with, but they also have their own graphical API, kind of like DirectX, if you ever worked with something like that, or Raylib. But yeah, go check it out. It's completely free. It's open source. Yeah, I've been meaning to look and see what people are doing with it, but maybe we'll do that on stream at some point, or I'll do like a little side vid or something. Yeah, but yeah, come here and read this. It's really cool. And yeah, okay, so now we'll get back to it. So, but that's what made me think of it. I saw nodes. I'm like, oh, I'm giving some shine. Okay, so and it contains people and the ancestral relationships, the edges of the tree, right? Edges being the arrows, the relationships. The family tree branching stops when you reach an ancestor you do not know, as in figure 14.1. Oh, I see. Okay. Modeling a family tree can be difficult because for any given person, you may know 0, 1, or both of their biological parents. If you know one or both parents, you would like to keep track of their ancestors as well. Consider an enum that might let you build up as much of your family tree as you know. Family. I got all mine under one enum called. I don't lend out money. No, I'm playing. Family tree case. That would be funny though to put your family in an enum. No known parents. That's unfortunate. Sometimes it's better to never have known than to have known and then lost. Okay, here, case, no known parents, case, one known parent, name. I used to know this guy that would spell unknown, uncone, there would be no N, and it used to piss me off. Oh my gosh. Ancestors, family tree, case, 2 known parents, 2 known parents, and hold on one sec. 2 known parents. Two known parents, you know parents, 2 known parents. 2 known parents. God dang it, that's long. Father, name, string. Yo, bring it out there for buddy. Paternal. Oh, you know what? Does this Command I? Man, I wish I knew why I was doing that. Edit. No, show font, show color. I thought, no, not that. For that's an interesting collection of weird Xcode. Huh. Yak and bison, really? That's interesting. Vim mode, wrap lines, authors. Stop wrapping my lines. Editor. Wait, what? If that's control 1, 2, escape 2. It doesn't work. Vector. Oh snap, you can. Oh snap, look at all that. Oh, brother. Oh man, I got off course here, but I wanted to see if there is a can you not do it? It sucks. How to equivalent Xcode. The reformat code command in Xcode is Control I, not Command I. Control I seems to have no effect. Yeah, what are you talking about? Oops. So if I do Control I, it just does indentation. Will it fix this? I hope so. It will not. Whatever, alright, fine. Let's get down here. Father name. Alright, we'll finish this out. So paternal ancestors, family tree. Fortunately, this will not compile. Family tree is recursive. Oh, it's referencing itself. Okay. Because we're inside of... I see. Okay. Family tree is recursive because its cases have an associated value that is also... of type family tree, and Swift treats recursive enumerations specially. To understand why, you need to know a little bit about how enumerations work under the hood. The Swift compiler has to know how much memory every instance of every type in your program will occupy. You do not usually have to worry about this, as the compiler figures it all out for you when it builds your program. Enumerations are a little different. The compiler knows that any instance of an enum will only ever store one case at a time. Although it may change cases as your program runs. Therefore, when the compiler is deciding how much memory an instance of an enum requires, it will look at each case and figure out which case requires the most memory. The instance will require that much memory plus a little bit more that the compiler will use to keep track of which case is currently assigned. Look back at your shape dimensions enum. The point case has no associated data, so it requires no extra memory. The square case has an associated double, so it requires one double's worth of memory, 8 bytes. The rectangle case has 2 associated doubles, so it requires 16 bytes of memory. The actual size of an instance of shape dimensions is 17 bytes, enough room to store a rectangle if necessary, plus 1 byte to keep track of which case the instance actually is. Now consider the family tree enum. How much memory is required for the one known parent case? Enough memory for a string plus enough memory for an instance family tree. See the problem? Yes. Yeah, it's non-deterministic is the problem. Okay, the compiler cannot determine how big a family tree is without knowing how big a family tree is. Looking at it another way, family tree would require an infinite amount of memory. To solve this issue, Swift can introduce a layer of indirection. Actually, maybe we'll save that for tomorrow. Pick it up with family tree 313. Man, time went by fast. But no, that was meaningful in terms of just this alone. So I feel good about it. So we'll cut it there. Jared will cut it there, and then let's plan on looking at that nodes. Maybe not tomorrow, but maybe like a weekend stream. That might be cool. Like a tool exploration. That might be a cool. I'm gonna write that down. Yeah, tag that down for me, Jared. Okay, anybody's still out there. Anyways, thanks for watching. That's it for today. That is episode 20 in the books. What's tomorrow? Friday? Yeah, we'll be back on tomorrow, 11-ish CST. Tune back in. Make sure you tune back in. And as always, if you are into gaming at all, make sure you follow me. See my Xbox tag there. Twitch, X. Follow me on X. I'm trying to get on it. I'm really just doing the Twitch thing just cause, but yeah, there's no shot. But on X, there's a shot. Yeah, so follow me. That'll be basically every night, 9 p.m. Central to whenever. I'll go for 2-3 hours, but yeah, if you like sweaty Halo, I'm deep in it. I'm on day 40 something of 100 days, trying to get back to that Onyx level. Slowly getting there. We're at Platinum 6 now, or maybe I dropped Platinum 5 or Platinum 6. So 7 tiers away, 50 days to do it. I think it can be done. So make sure you tune in for that. Otherwise, see you tomorrow. Thanks, everybody. Peace, love, and prosperity.